Hello everyone, welcome to Wings of Physics. Myself Deepali Kulkarni from PVP Junior College, Pravaranagar, Loni. Today we will start a new chapter and name of the chapter Electrostatics. All the concepts in this chapter, that is imaginary concept. So please listen carefully each and every point of this chapter. Okay. Now we will study about the basic concepts related to this chapter. First concept, that is electric intensity. First is electric intensity. What is the concept of electric intensity? Electric intensity, that is denoted with the letter capital E. It is a vector quantity. Then what is the concept of electric intensity? Suppose a point charge. Suppose this is a point charge. It may be positive, it may be negative. There is a field around this charge. Means that charge itself produces a field and another unit positive test charge. Suppose this a Q0, that is a unit positive test charge, is bring within that field. At that time what happened? This charge that experience a force and the force per unit, this unit positive charge means E, that is nothing but the force experienced per unit, this unit positive charge, that is called as electric field intensity. Then one another formula used for electric intensity, that E, that is equal to dV by dx. That is the another formula to calculate the electric field intensity. And by using these two formulas, unit of electric intensity is, first unit is Newton per coulomb or volt per meter. These are the two SI unit used to measure the electric intensity, and we have to use this unit frequently in this chapter. So please keep in mind that the SI unit of electric intensity is Newton per coulomb or volt per meter. Then what are the dimension of the electric intensity? The dimension of electric intensity, E, that is equal to the dimension of force, that is L raised to 1, M raised to 1, T raised to minus 2. That are the dimension of force. And dimension of charge, we know that current, that is nothing but the rate of flow of charge. And therefore, the dimension of this charge, that is I into dt. I means the current. Ampere, that is the current. And T means the T raised to 1. Then total dimension of electric intensity is L raised to 1, M raised to 1, T raised to minus 3 and ampere raised to minus 1. These are the dimension of electric intensity. Then it is vector quantity, and suppose the Q is the positive charge, then the direction of electric intensity is in this direction, means it is in outward direction when charge is positive. Then if charge is negative, suppose this point charge is negative, then direction of intensity is in the inward direction. And these are the notations used for the electric intensity. When charge is positive, it is in outward direction. When charge is negative, it is in inward direction. And this is the direction used to denote the electric intensity. And this is all about the electric field intensity. And the definition of electric intensity, I repeat, the electric intensity at any point is equal to force experienced per unit positive charge, that is called as a electric field intensity. Are you getting my point? Then second concept, that is the electric flux. Electric flux. electric flux. Second concept, electric flux. Electric flux, they are denoted with the help of letter phi. Phi is the notation. Okay. Then suppose this is a ds area. Now ds, that is a area vector. ds, this area, that is a area vector, and direction of area vector, that is always, suppose this is the area, and direction of area vector, that is always a perpendicular. Okay. Then ds, that is the area, and in that area these are the field lines. They are passing normally through this given area. Then the number of field lines passing normally in the given area, that is called as a electric flux. Okay. Then the electric flux d phi in the area ds, that is nothing but E into ds. That is the dot product. Why we have to use dot product? Because we know that in the dot product of magnitude of two vector and cosine of the angle between them. When these two, suppose electric field intensity is in this direction and area vector is in this direction, both are in the same direction, then angle theta, that is 0, and if cos theta, cos 0, that is equal to 1, at that time we get this number of flux in this manner. And if we use cross product, at that time they are in the same direction, at that time sine angle is there, sine 0 is 0, and therefore we get 0 number of flux, and that's why we use the dot product. Okay. And therefore the d phi, that is the flux in the area vector ds. We can increase the flux by using two different methods. If we increase the number of field lines, means we can increase the intensity. At that time, the flux that will increase. And one another method, suppose this is the area vector. At that time, number of field lines are larger. Okay, means if the number of field lines are larger, they are passing normally. At that time also, if we increase the area vector, number of flux, they are also increased. And these are the two methods to increase the flux. Okay. Then the SI unit of electric flux, then phi, that is equal to line integral over a closed surface E into ds. This is the formula to calculate the total flux in the given area. Then the SI unit of intensity, just now I told you, that is Newton per coulomb into ds, means area, meter square. This is the first SI unit to calculate the flux. And second SI unit, if we use this unit of intensity, that is Volt per meter, and into meter square, then it becomes Volt into meter. These are the two SI unit used to calculate the flux. Also, we can calculate the dimension of flux, that is nothing but the dimension of intensity, that is L raised to 1, M raised to 1, T raised to minus 3 and A raised to minus 1. And if this ds having dimension L raised to 2, then total dimension becomes L raised to 3, M raised to 1, T raised to minus 3 and ampere raised to minus 1. These are the dimensions of the electric flux. Okay. This is about the flux. Also, always keep in mind that the number of flux, they do not depend on the shape and size of the this surface area. Okay. Then that surface, imaginary surface, that may be called as a Gaussian surface, and number of flux, they do not depend on shape and size of the Gaussian surface. Okay. Now we have to study about the Gauss theorem. Gauss theorem. Gauss theorem. the mathematical statement of a Gauss theorem is phi, that is electric flux, that is Q divided by epsilon naught, or it is a surface integral of E into ds, and that is nothing but surface integral of E into ds into cos of theta, where theta is the angle between electric field intensity and area vector. This is the mathematical statement for the Gauss theorem. Then, to explain the Gauss theorem, consider a surface and a charge is supplied to that surface. Suppose these are the charge supplied to that surface. Then consider a imaginary surface. This is imaginary surface, and that imaginary surface is called as Gaussian surface. Okay, this imaginary surface, that is called as Gaussian surface. Now, the net charge enclosed by this Gaussian surface, they are Q. Then, the electric flux over this closed surface, that is nothing but, means over this Gaussian surface, that is nothing but the 1 by epsilon naught times the net charge, means Q is the net charge, and Q net divided by epsilon naught, that is the mathematical statement of the Gauss theorem. Okay, I already told you, means the total flux in over this Gaussian surface, that is equal to Q net divided by epsilon naught. Epsilon naught, that is called as a permittivity of a free space, or it is also called as a permittivity of a vacuum, and its value is 8.85 into 10 raised to minus 12 coulomb square per Newton meter square. Okay, this is the value of epsilon naught. And again I repeat, this flux over this surface, over this Gaussian surface, that does not depend on size and shape of this Gaussian surface. Okay, then the surface integral of electric intensity over a closed surface in a free space is equal to the Q net divided by epsilon naught, or 1 by epsilon naught times the net charge enclosed by that surface. This is the statement of Gauss theorem. Are you getting my point? Okay. Now, by using this Gauss theorem, we have to calculate the electric intensity of 3 different cases, that is nothing but the application of a Gauss law. Then first application of a Gauss law, that is the electric intensity due to uniformly charged spherical shell or hollow sphere. Okay. For this purpose, consider a sphere. This is a hollow sphere of radius r, and O is the center of that sphere. Then the sigma, that is a surface density. What is the surface density? Charge per unit area, that is called as a surface charge density, and sigma is the uniform surface charge density of this sphere. Then from this formula, Q, that is equal to, means charge over this sphere, that is nothing but sigma into A, and this area is, if R is the radius of this sphere, then 4 pi r square, that is the area of this sphere, and this is the equation number 1. Now we have to find out electric field intensity due to this charged sphere. For that purpose, consider, we have to find out electric field intensity at point P, where ds is the area is there, and ds is the area vector, and that is perpendicular to that sphere. Then draw a Gaussian surface, this imaginary sphere, that is nothing but a Gaussian surface, and it is having radius small r, and we have to find out the electric intensity at point P. Then just now I told you, when charge is positive, then this is the direction of electric intensity, and E and ds, they are in the same direction. Means the angle between these two vector, angle between the electric intensity and area vector, that is 0. Theta, that is equal to 0 degree, and therefore cos theta, that is equal to 1. Then according to the mathematical statement of a Gauss theorem, electric flux over this closed surface or over this Gaussian surface, that is nothing but Q net divided by epsilon naught. This is equation number 1. Then second, according to the second formula, surface integral over a closed surface, that is nothing but the dot product of E into ds. Then the surface integral of E into ds into cos theta. If theta that is equal to 0, cos theta that is equal to 1. Then surface integral of E into ds. Now this E intensity, that is a constant. Means here at this point intensity is E. At this point means over this whole Gaussian surface electric intensity E is constant, and therefore it is taken outside the integration sign. Phi that is equal to E into surface integral of ds. Now the total area of this sphere, that is nothing but 4 pi r square, small r square, because small r that is the radius of that Gaussian surface, and it becomes E into 4 pi r square. This is the equation number, this is 2 and this is 3. Then comparing equation 2 and 3, we can write Q by epsilon naught, that is equal to E into 4 pi r square. We have to find out electric intensity. Then value of E, that is equal to 1 by 4 pi epsilon naught Q divided by r square. This is the first value of the electric field intensity. This is equation number 4. Then if we substitute value of this Q, that is equal to sigma into 4 pi r square, then E that is equal to 1 by 4 pi epsilon naught sigma into 4 pi r square divided by r square. Then what happens? This 4 pi that gets cancelled, and sigma into r square divided by epsilon naught r square. This is the another formula to calculate the electric intensity. This is in terms of a charge Q, and this is in terms of surface charge density. Now we can calculate the electric intensity on this sphere whose radius is small r. At that time substitute value of this r, that is equal to small r, means r that is equal to r. Then electric intensity E that is equal to 1 by 4 pi epsilon naught Q divided by r square. If we substitute value of this Q, that is equal to again sigma into 4 pi r square divided by 4 pi epsilon naught r square. Then this 4 pi r square that gets cancelled, and E that is equal to sigma divided by epsilon naught. These are the two value of electric intensity, where r that is equal to r, means on this sphere this is the value of electric intensity. Then inside this sphere, what is the value of electric intensity inside this sphere? Inside this sphere no charge are there, means sigma that is equal to 0, and if sigma that is equal to 0, then no charge, net charge inside this sphere, that is 0. If sigma that is equal to 0, Q that is equal to 0, then flux will be 0, and therefore electric intensity is 0. Understood? Inside this sphere, E that is equal to 0. Always keep in mind that inside this sphere electric intensity is there, and by using this Gauss law we can calculate the electric intensity over this Gaussian surface, and this is the use of a Gauss law. Understood? I hope all of you understood this all concept very well. If you like this video, then like, share and subscribe my channel, and also press the bell icon to get notified about my new upcoming videos. Thank you very much.
Oh,